About the attribute, we have seen a couple of days various things like the characteristics of attribute. Sorry, yeah, correct. Like well-known, mandatory, discretionary, optional, transitive, non-transitive, partially marked update, so on. Then we learned what is AS path. BGP has got this AS path attribute, local preference, next stop, origin, MED, always in its advertisement packet. Whenever we capture a packet, BGP update packet, we will always find these five things for every single network destination. These attributes will be always seen. But though it is always seen, the mandatory to be seen is only the first three. So AS path, local preference, sorry, AS path, next stop, and origin, they are the mandatory one. Local preference and MED, if it is there, good. If it is not there, also no problem. As I said earlier, local preference will not be advertised while advertising a route to eBGP. And MED will be always remaining zero only in a dual home scenario. When you configure, it will have some number. Only then it is going to be used. So these two things are well known, discretionary, not mandatory. Even if it is not available in the update, it is okay. But the first three things must be seen in all BGP route updates. I'll capture some other day when I do the lab. I'll capture a packet and I'll show you this. Network layer reachability NLRI list means the prefix that is advertised by an IBGP or eBGP will always have these things. So about AS path, we learned that whenever we receive an update, a prefix, we always see the AS path via which this advertisement is given to us. In our example, it is just two autonomous system number. You will find if you are in router B, you will find only two autonomous system, this and this. But in the real world, it's going to be many number, depending on from where the prefix is coming. In a lab environment, you may maximum see 5 hops. We don't do more than 5 autonomous system for learning. Our next stop, eBGP address will be carried into IBGP. As a result, router C, when it learns 172.16.0.0, it will learn 10.10.10.3 as the next stop. So the previous one, AS path attribute, and this one, and the next one, all these three are well-known mandatory. Origin is well-known mandatory. Next up is well-known mandatory, like AS path. So So when we talk about the origin attribute, which is also a well-known mandatory, what is the use of this attribute? This is going to inform us how the prefix is added into BGP. You can add a prefix into BGP by advertising using network command under BGP, or it can be learned from an EGP protocol, which is an older version of BGP. So when you redistribute from EGP into BGP, that has got special marking called E. But when you redistribute from some other protocol like OSPF or static route, the marking will be question mark. I is advertised in BGP by using network command. E is advertised in EGP and redistributed into BGP. And question mark is redistributed from some other routing protocol like OSPF, ISIS, or static route. Always lower is preferred. If three sources coming, one is giving I, another one is giving E, another one is giving question mark for the same network, I will be preferred. If no I, only E and question mark, then E will be preferred. So the second last paragraph, the 3-line, is what very important to know about the origin attribute. Origin attribute informs all the autonomous system. It informs not just one autonomous system next to this autonomous system. It informs all autonomous systems. In the internet, even if you have 100 hops, the 101th hop will be very clearly showing you how on the very first autonomous system the network got added into BGP. It shows how the prefix were introduced. So this sample output shows us the prefixes and the attributes. For example, this prefix 10100 is learned from two different sources. One is local. This is local. Where it is originated? It is locally originated on the router. That won't come under I or E or question mark. That will not come under. This is different. This is origin code is different. This tells locally advertised. Locally originated is different from origin code. Both are attributes. Locally originated is the next up attribute. Locally originated is preferred compared to the one which is originating from some other neighbor. See, in this autonomous system where router A is, there are two routers which is advertising this network. One is this router A itself. The other one is maybe B router. How do I know? It is coming from local because I have local preference. 100. This is not coming from any other autonomous system. This network is given by two different routers in the same autonomous system. One is router A, the other one is maybe router B. This is the address from where I'm learning this network. Yes, sir. What, sir? Ah, that is administrative distance. This is not routing table. You are not seeing routing table. You are seeing show IP BGP forwarding table of BGP. This is not showing administrative distance. This is an attribute called local preference. This is different. That is different. Whatever you see in the routing table is what? Administrative distance. There you will find 200 for IBGP and 20 for EBGP. You understand? This is different thing. All right, this is different. And what are the other things that we learn? The default metric. Metric is nothing but MAD, multi-exit discriminator. So instead of writing that big MED, multi-exit discriminator, in short, they write it as metric. This metric will come into picture only if you have dual homing. Next. AS path attribute. It shows that this network is actually born, given birth, originated in this autonomous system. From there, it was advertised to this autonomous system, from which the local autonomous system, router A, has learned it. This R stands for routing information based failure. It is not failure because of BGP. It is not something very serious. RIP failure is routing information based failure. It means BGP has given it, but RIP is not ready to use it. BGP said routing table manager. BGP says routing table manager that this is good. Take it. Very healthy to eat. Take it. Eat it. But the routing table manager says it's okay. I have eaten this enough. I have something better. Same network. I have a better administrative distance. So let me use that. I don't want this. You see? Let's say BGP says IBGP gives a route. IBGP means what? 200 administrative distance. IBGP gives a route. OSPF also gives the same route. OSPF also gives the same route information for a destination. BGP gives a path to a destination. OSPF also gives a path to a destination. But IBGP is 200, OSPF is 110. So routing information base will say, I'll use OSPF, not BGP. That is how that is how RIP failure comes. That is how BGP will generate this to tell you, I'm giving, but he's not ready to use it because he has got something better than what I'm giving. So this is not a big error. It is just showing you that even though I have this information in my database, packets are not forwarded as per this. Packets are not forwarded as per BGP's design, BGP's decision. That is what RIP failure is. Please ask me if you have question on RIP failure or anything in this page. Hmm. You see, even if I do some summarization, if the summary route of the routing table matches with the learned route coming from outside via BGP, then also the summary route's administered distance is always lower compared to any other protocol. That is another reason. But RAPE failure always administrative distance related only. On the same router where you are showing this output, the network is, yeah, correct. No, the network command, how do I know it is either network command or redistributed? Because of this only. It may be locally redistributed also. 0000, it may be locally redistributed. And then here instead of I, you will have question mark. Right, now, what we have seen is only three attributes we have seen so far. One is AS path, next is origin code, then next hop. We will be learning something called weight. The default weight is 100, sorry, 0. The default weight is 0. But whenever you see next hop as 0000, this is what dynamically given as a default weight. Understand? Weight default is 0 for those routes learned from other autonomous system or another router. It may be same autonomous system. If you are learning route from another router, it can be eBGP or IBGP, that doesn't matter. If you are learning route from another router, if you are learning some prefix from another router, the weight is going to be 0 by default. But when we advertise a network locally, when our next hop is going to be 0.0.0.0, the default weight is 32768. It is default. You can change it, but this is default. This is default. Weight is one of the attributes which we are going to learn today, maybe in the following pages. Now, local preference is another attribute that we'll be learning. Local preference will be 100 if you are learning from IBGP. This is an IBGP router from where I'm learning the same network, so that's 100. For local advertised, you will not see. Only when you learn from another router. See, this is same local router. This one, this is the same local router. But these are, no, this one is null, means it's eBGP. Learning from eBGP. Right, this 100 won't come here actually. So, oh, repeat again. Hmm. Yeah, this one and this one are advertised locally on the router, also by the neighbor router. Oh, this is different. Yeah, first one and third one is advertised by the same local. See, this is local preference attribute. See, local preference is like telling every router in your autonomous system which exit to be taken in order to reach a prefix destination. Repeating again. Local preference is like a father in the family. Father in the family, what he will do? He'll give instruction to children, and all the family member will obey because he is father. Father says, see, there are two gates in our house. Don't take the left hand side gate. Prefer going via right hand side gate. So he tells this to one of the child. That child goes to all other children and informs the same. Now, not only that child goes via right hand side gate, every children in the house, every member of the house goes via the right hand side gate. Because father has said, take the right gate, not the left gate. Because he's the head of the family. The decision that he makes is the decision of entire family. That is what local preference is. For example, if you see here in this autonomous system 65350, do you locate that 64520? In this autonomous system 64520, in order to reach this autonomous system here, even though this is just 1 2 hop, father has said, I prefer this gate. By giving bigger number, we say this is the exit router preferred to go to autonomous system 65350. This one. This is the A is the best exit. The default is 100. When you give more preference, every router, all chota bachas, all small routers inside, everyone will follow the same instruction. All small router will follow this path. Including B will go this way. But it is not really configured on every router. It is only configured on this router. It is the respect given to the father by children. All they want to go this way because father has told us. Father goes via that way. My dad goes through that way. So let me also go through that way. That should be the right path to follow. Let me choose the path shown by my father. Given high preference, actually it was configured only on router A, but every router learns from A that A has got more local preference than B. So if you have a policy in your organization where you want to use router A to be an exit, the entire autonomous system should use A as an exit, then you may go and tune local preference. That solves the problem. If you don't have this attribute, you have to go to every router and show go via this way, go via this way. You need to say every router, a policy based routing, you need to use a route map and say point towards this direction, which is very difficult job, no? Simply by creating a local preference value on A, B, C, D, E, F, G, H, I, J, K, L, all routers in this autonomous system will go via A. You don't need to go to any other router and say follow A. No need to say that. That is what you see in the very first point you read. Local preference is used to advertise to IBGP neighbor about how to leave this autonomous system. It is advertised actually. You configure on one router, you configure it on router A, immediately advertisement goes to all IBGP router, meaning all the router within the autonomous system, telling that you have to leave via router A because router A's local preference is higher than router B's local preference. The local preference is sent to IBGP neighbors only. Very important point. Even though local preference is a well-known attribute, it is not a mandatory one. You see, it cannot be a mandatory also. Why? This will not be advertised to EBGP neighbor. It is advertised only to IBGP neighbor. Local preference is sent to IBGP neighbors only. Local preference attribute is well known and discretionary. I told you, right? It's not a mandate. The default value is 100. Please ask me a question.
So this local preference is shared within the autonomous system through IPG by all routers, and they know that this is for this particular router. This is the
Exit. Yeah.
So does it change? Does it like affect the next behavior on the other router on that router?
Yes. Yes. Every router in that autonomous system will change its routing table, the next hop address, towards router A. Earlier, it may be pointing towards B when you don't configure local preference. But as soon as you go to A and configure high local preference, immediately the triggered update goes to everyone and tell that A has got 200. So the routing table of every router who learns this 200 as a local preference of A, they will change their gateway address now. They will change it immediately. You will see that immediately. Automatically it will change.
So let's say there is already some traffic going outside of this system from the mesh already.
I know it is going to be a disruptive one.
So it discards the
Yes. Of course, because then The routing table is going to change the gateway. When you change the gateway, ARP will start working. ARP will learn the new gateway's MAC address. And then if ARP table is not updated, it will do this. Otherwise, it will take a slight downtime, few seconds downtime. But there will be some drop.
So this will only affect the outgoing traffic, the incoming traffic they are not talking about.
Correct. Correct. It is only for outgoing. Yes. Okay, his question is A is advertising 150, sorry, 200, B is advertising 150. If C receives it here, will it receive both or only it will receive from A? It will receive both and then it compares both and it prefers to go via A. Check G. ரெண்டுத்துக்கிட்ட இருந்தும் வாங்கும் பி 150 சொல்லியிருக்கிறானு தெரியும் அதுக்கு ஏ 200 சொல்லியிருக்கிறானு தெரியும் நான் ஏ வழியா போய்கிறேன் அப்படின்னு சொல்லி ஏவை மட்டும் ரவுட்டிங் டேபிளில் போட்டுட்டு it will install the route via A in the routing table and it will still maintain the route via B only in the BGP table. In the BGP table you will see both, but in the routing table you will have only path via A. Okay, let's move on to the next one. Multi-exit discriminator, MED. Multi-exit discriminator. What is the purpose of MED? When we have multiple exit, see, router A has got multiple exit. Router A has got multiple exit. Kindly understand this scenario. This is the attribute which many people are not clear. MED, even though you are going to configure it on B and C, the impact is going to be on A. MED you are going to configure not on local autonomous system, on the upstream autonomous system, the neighbor autonomous system. You configure it on B and C, but the impact won't be there on B and C. The impact will be on A. A has got multi-exit. A can exit via this way or this way to reach this network. Now, this autonomous system wants you to exit this way. Only when this fails, this way. Who decides it? This is deciding. This decides that you should always use this path as a preferred path. And only when that fails, you may use this one. Who wants this? This wants this. It's not your policy, it is this policy. When I say this, I mean the autonomous system where I written this autonomous system wants you to receive your packet via this link, via the primary path. Who wants? Not A. It's not A's policy. It is a policy of 65500 autonomous system. 65500 autonomous system. So what they do is they go and set a small MAD on one and the big MAD on the other. Smaller is preferred. MAD lowest is always preferred. The default MED is 0. I told you, no? I showed you also, you see. The default is 0. In this example, they have set 150 and advertising this 172 network, 172.20. And via this way, it is coming with 200, 172.20. A says, I'll go via this B because 150 is better. Let's read the remaining lines. MED is used to advertise to EBGP neighbor. That's what I was telling you. You configure on B and C, the impact is made on A. MED is used to advertise to EBGP neighbor how to exit their autonomous system to reach this autonomous system in this network, the networks in this autonomous system. This, there, towards this autonomous system. This is this. How there. AS can reach to reach the network in this autonomous system. MAD attribute is an optional, non-transitive. See, even though it is an optional one, if it is not found, it will discard. At least 0 should be there. That is why you see here 0. If this is not seen, it is going to discard the update. It is non-transitive if not found. What is non-transitive? You see? Discards if not recognized. MAD attribute is an optional and non-transitive. Wait. Wait is another attribute. This attribute is Cisco only. And this is the attribute similar to local preference, but the difference is local preference is like father using a gate, all the children follow that gate as an exit. Wait is like a visitor in your house wants to leave your home. A visitor in your home, he wants to leave your home. Will they follow some rules? No. Because they are visitor, you won't insist them to go via the right hand side gate. He prefers to go via left. He will go via left. Will anyone else follow him? No. Because in the family, you have decided to go via the right. Wait is local to the router. Say for example, here you have said more weightage to this neighbor 200 than this neighbor. Both the neighbors are giving me path information to reach this 172.20 network. But A prefers to go via B because the weightage is higher. Higher is preferred. But if I'll have another router here, let's say router H, it may go via this way also. That weight will not be advertised. Weight won't be advertised to IBGP neighbor nor EBGP neighbor. It won't be advertised neither to IBGP nor to EBGP. It is local to the router. Did you understand the difference between local preference and weight? Did you understand the difference between the local preference and the weight? Right. Local preference is local to the router. Weight is local to the autonomous. Sorry. Weight is local to the router. Local preference is local to the autonomous system. Yes. Yeah, it prefers to go via the neighbor for whom the weight is higher. Mm. Right? Fine. So we'll stop here. We'll continue this. To an extent, we have covered the important attributes. We have seen MED, we have seen local preference, origin, next up, even we have included weight. Okay? So the remaining thing we have to learn after learning some basic in routing. So we'll cover these things in next class. See, there are some routing basics. This is not BGP related. I've included some pages here in the middle to teach some fundamentals before getting deep into attribute list. We'll keep it as a separate session. Hope you enjoyed today's session. Thank you so much for joining. See you in the next class. Take care. Bye. Good day. Bye.